Hello all, once again welcome back. So in this today's session we'll see, right, so what is the meaning of, right, so meaning of something called as the excitation table. The another name for this one is application tables, right. So then where we are using these application tables or excitation tables we will see, right. So once it is done, for each and every flip-flop, nothing but for SR flip-flop, for D flip-flop, for JK flip-flop, for T flip-flop, we will write the excitation tables, right. Excitation table or application table. This is the agenda or objective of the today's class, right. So first we will see that what is the use of the excitation table, right. So excitation tables are useful when you are converting something. For example, if you have the something flip-flop called as the SR flip-flop, you have the SR flip-flop, we need to convert in terms of the JK flip-flop. It means that when you have the SR flip-flop, if you want to convert in terms of the JK flip-flop, then we require two things, right. So what are the things we required is that first one is that truth table we required. The second one we required is the excitation table, or one more name this we can call it as the application table, right. So where we are using the excitation table or application table means when you are converting the one given flip-flop to the another flip-flop, we require the excitation table. Fine. So this kind of situation we require the excitation table or application table. Then one more point to remember here is that if you consider SR flip-flop, so what is the input value you will be getting? SR Qn plus 1, right. It means that these are the input values. This is called as the present state or assumption output. This is called as the next state. NS means next state, PS means present state. Next state or final output value, as we discussed in the previous classes. Now if you consider the excitation table or application table, one more point to be remember is that the output of the flip-flops, right, the output of the flip-flops are used as the input and input of the flip-flops are used as the output. So what is the meaning of this one is, for example, if you consider the SR flip-flop, inputs are SR, outputs are Qn plus 1. But in case of the excitation table, the outputs are taken as the inputs are taken as the output value. For example, if you want to draw the excitation table for the SR flip-flop, first we require two things. The first thing we required is the flip-flop is what? SR. For SR flip-flop, we need to draw the truth table operation, right. With the help of this truth table, we are going to find out the excitation table for the SR flip-flop. First we will draw the truth table for SR flip-flop, right. So SR Qn plus 1. So this is the assumption value, this is the final value. Qn is the assumption value, then Qn plus 1 is the final value, right. You have to remember, guys, right, we discussed in the so many classes, right. So 0 0 0 1 1 0, each input we are taking the twice. Reason is that either assumption may be 0 or 1, so for that reason we are considering the two times. So 0 1 0 1 0 1. What is the output? When s equal to 0, r equal to 0, this is called as the no change condition, right. No change means 0 means 0, 1 means 1. What is the next condition? When r is activated, reset is activated means output should be reset. Reset means either if you give 0 or 1, output should be reset means output should be always 0 only. Now what is this condition? 1, right. So s equal to 1 means which is activated? Set is activated. Set is activated means output should be always 1. So it means that either you are giving 0 or 1, output should be always set as the 1. That is the meaning of set condition. When s equal to 1, r equal to 1, this is we called as the invalid condition, right. So first we have complete the truth table. Now we can write the excitation table or application table, right. As we discussed in excitation table, outputs are considered as the inputs are considered the output, right. If we see that Qn plus 1 are the assumption first level output, final level output, right. So for here, in case of the excitation table, the inputs are the outputs are the inputs. So it means that output of the flip-flop is what? Qn plus 1, right. That we need to consider as the inputs, right. So now what will be the output value? Try to guess. The output values are the SR. This table we have to fill out. Then this will be our excitation table for the SR flip-flop. Now if we see that how many inputs we have, two inputs, right. It means that 0 0 0 1 1 0 1 1 are the possibilities value, right? Now first what we will do is we will take the qn plus 1 value. Based on that we will find the SR value. What is the first condition we will try to take? 0 0. For that what is the value we need to find out? S value as well as the R value we need to find out. Now question is that from where to find out, right? So the simple thing is that if you want to find out the excitation table, what is required? We require the truth table operation. If you know truth table operation, then excitation table is nothing. With the help of the truth table we can find out the excitation table answer, right? So this is the truth table of SR flip flop, right? Now see that this is the very important point that you have to remember is, so what is the first input condition? 0 0. It means what is this value? qn plus 1. It means that what is the value? Qn equal to 0, qn plus 1 equal to 0. Again I am repeating. So qn plus 1 value equal to 0. You just go through the truth table of the SR flip flop and you find out where we have the qn plus 1 equal to 0 0. Again I am repeating, this is the important. You just go to the truth table of the SR flip flop, then you find out where we have the qn plus 1 value equal to 0 0. If you find that 0 0, then just you note down what is the S value, R value. That is the thing you have to do here, right? So if you see that where we have this is the qn plus 1, right? What is the first input condition? 0 0, right? So here we have the 0 0, right? What is the S value, R value? The S value, R value is what? 0 0. Just you write here 0 0. Now one more important point you have to do is, again you check, is there any first 0 0 is completed, right? Again you check whether there is one more 0 0 is there or not. See, if you observe here, it is not there, but here we have the 0 0, right? Just try to look at this. What is the qn plus 1 value we are considering? 0 0. Here also we have the 0 0, right? What is the SR value? 0 1. That value also here we need to note down, right? So for 0 0 condition, what is the one more value we are getting? 0 1 is the value, right? 0 1. Now if we see that how many combinations we are getting? 2 combination, but here how many values we can able to represent? Only 1 combination. It means that here we got 2 combination, but here we can able to represent with only 1 combination. Now what we have to do is, somehow we need to convert this 2 combination in terms of the 1 combination, right? Try to understand. Here we can represent only 1 value, but here how many values we got? 2 values. Somehow we need to convert this 2 value in terms of the single value. So how to find out means, simple logic is that just try to remember this one. If both the values are the same, we can write as the 0. It means that no change, no change. Both the values are same. We can write instead of 2 zeros, like repetition operation, we can write the 0. Or if we find something 2 values equal to 1, we can write in terms of the 1, because both are the same values. But in some cases you might be finding 0 1 or 1 0. It means that it is not completely 0 or it is not completely 1. It means that either it may be 0 or it may be 1. So we know that if it is 0 or if it is 1, we used to represent with the don't care combination. I again repeating, same value means we can write the 0, same value means we can write the 1. Either if it is maybe 0 or if it is maybe 1, we can write the don't care condition. Now see that this is the S value, right? This is the R value, right? So this is the S value, right? What is the meaning of 0 0? Same value, right? We can write the 0. What is the R value? Here if you observe here, different value, different value, different value, different value means we can write the don't care. It means that we are converting 2 values in terms of the single value. Now what is the final answer? When qn plus 1 equal to 0 0, what is the S value, R value? 0 cross. Just you copy this value here. That's it. Right. Now we'll consider the one more condition. What is that condition? qn plus 1 equal to 0 1. Right. For that what you have to find out? We have to find out the S as well as the R value. Again what you have to go to the truth table. Just go to the qn plus 1 value. Just locate where we have the 0 1. Where we have 0 1? See here we don't have 0 1, 0 1. So here we have the 0 1 combination, right? What is the S value, R value? 1 0. Is there any other 0 1s are present here? No, only we have the single 0 1 of the qn plus 1. For that what is the SR value? 1 0, right? Now if you see that only we are getting single combination, right? It means that we don't even need to make the conversion. If you get the 2 possibilities or 2 combination, we are going to convert into the single combination. Here if you observe here, Anyway, we got only single combination, right? No need to requirement of again conversion, something like this. Directly we can copy this value here. What is the answer? When 0 1 means the answer is 1 0. Next you consider 1 0 condition. So qn plus 1 equal to 1 0 condition. Find the SR value. So again what you have to do? Just go to the truth table. qn plus 1, where you have the 1 0. Here we have the 1 0, right? Which one? Here we have the 1 0, right? What is the SR value? 0 1. Check out, is there any another 1 0 is repeating? No, right? So what is the final answer? 0 1, right? Now finally we will consider the one more combination. What is that final combination? qn plus 1 equal to, when it is 1 1, what is the S value? R value, right? Again go back to the truth table. Here we have the 1 1, right? What is that input value? SR value 0 0, right? Just you write down 0 0. Again you check it whether there is again one more 1 1. See here, don't care means no need to consider, just you check only 1 1 is there or not, that's it. For 1 1, what is the value? 0 0, that is already done. Next, is there any 1 1? So if you observe here, we have 1 1 here. So what is the SR value for this one? 1 0. Just to copy this value here, 1 0. Now here we have the two set of value which need to be converted in terms of the single set of value. So how to write out this value? 0 1 means cross, 0 0 means same value means 0. What is the answer? Cross 0, right? So this is how we are going to find out the excitation table for the SR flip-flop, right? So this is right. So in the same class what we will do is we will try to find out the excitation table for the remaining flip-flop also, right? Next, what is the D flip-flop? So for D flip-flop we need to find out the excitation table or application table, right? So let me first, what is the first step? We need to draw truth table for the T flip-flop, right? So what is the truth table? qn plus 1, right? So either it may be 0 input or 1 input. What is the assumption? 0 1. So D flip-flop means input equal to output, right? So 0 0 1 1. This is the T flip-flop truth table, right? So step 2, we need to draw the excitation table for D flip-flop, right? So in the excitation table, inputs are equal to outputs of the flip-flop, outputs are the inputs. So it means that qn plus 1 equal to input, D equal to output. So how many inputs we have? 2, right? So how many possibilities? 0 0 0 1 1 0 1 1. Now how to find out the excitation table? With the help of the truth table operation, right? So first, what is the input combination we are taking? 0 0, right? Just take 0 0. Go back to the truth table and find out where we have the qn plus 1 value equal to 0 0. See that here we have the 0 0, right? What is the D value? 0, right? Just you write the D value, right? 0. Is there any combination which is represented with 0 0 in qn plus 1? Only single representation, no other representation, right? So what is the answer? The answer is 0. Next, again you take the 0 1, right? So find out the D value. So if you see that here we have the 0 1, what is the answer? The answer is 1. Directly you can write it. Next, what is the combination? 1 0. Guys, here I am not going to invest the much time, because if you understand the excitation table for SR flip-flop, these all are nothing, right? So next, 1 0, right? So 1 0 means only single combination of qn plus 1, right? What is the answer? 0. Just write down 0. Next, for 1 1, what is the output value? For qn plus 1, qn plus 1 1 1, what is the output value? 1. So this is the excitation table for the D flip-flop, right? So now we will try to find out the excitation table for the JK flip-flop. So these are the truth table for JK flip-flop, right? So these are the input value, this is the output value, right? So truth table is completed, right? So just what is the truth table? Let me explain. First one is no change, second one is reset. Reset means always output should be 0. Set, then final one is the toggle. Toggle means 0 to 1 or 1 to 0, right? So first step is drawing the truth table, second step is excitation table for the particular flip-flop, right? So inputs are qn plus 1, outputs are the jk, right? How many possibilities? 0 0 0 1 1 0 1 1, right? We need to find out the j value as well as the k value. First we will take qn plus 1 equal to 0 0. For that we will write the corresponding jk value. For that what we have to do? again go to the qn plus 1 value, there you find out the where we have the 0 0, then write the corresponding jk value, that's it. So where we have the 0 0, here we have the 0 0, right? What is the jk value for this one? 0 0, right? Just to write down 0 0. Next, is there any 0 0? Again check out. Right, again here we have 0 0, right? What is the jk value? 0 1, right? How many sets we got? 2, but we can able to convert in terms of the single set, right? So what is the meaning of 0 0? 0, same value. 0 1 means don't care. What is the answer? 0, don't care. Now we consider the condition 0 1, find out the jk value, right? So see here we have the here 0 1. What is the jk value? 1 0, right? So next, is there any 0 1 again? Yes, here we have the 0 1. What is that value? 1 1, right? So what is the answer for j? Same value means 1, different value means cross. What is the answer? 1 cross. Now what you will do is just try to pause the video, then find out the output for 1 0 as well as the 1 1, right? So the answer will be something like this, right? So this is the excitation table for the jk flip-flop, right? So final one is excitation table for the t flip-flop, right? So this is the truth table for t flip-flop, right? So excitation table means qn plus 1 t. So 0 0 0 1 1 0 1 1, right? So if we take 0 0, this value is 0 0, right? What is the t value? Directly 0. No other 0 0 combination if you look at this one. Next, what is the value? 0 1, right? So this is a 0 1, right? 0 1 means what is the t value? 1. Next, what is the value? 1 0, right? qn plus 1, you look at 1 0 means what is the value? 1. Next, 1 1 means what? 0. What is the excitation table for t flip-flop? This is the excitation table for the t flip-flop. This is how we can find out the excitation table with the help of the truth table. What is the where we are using this excitation table means when you are trying to convert the one given flip-flop to the another flip-flop, at that time we are using the excitation table or application table. In one more thing, when you are designing the synchronous counter or parallel counter, there we are using the excitation table a lot, right? In the 5th unit we will see when we are trying to design the synchronous counter or parallel counter, there we are using the excitation table of the particular flip-flop, right? Thank you guys. Thank you very much.